With the latest update of WEST, you get access to a new sample project demonstrating the updated Influent Fractionator tool. This probabilistic fractionator creates a detailed influent composition by aligning model component concentrations with plant measurements. It uses sequential regression to fit component concentrations to available data or estimates derived from these measurements when data is missing. Measurements do not have to be complete or on the same time schedule. In our sample dataset, we have continuous water and solids measurements taken 4 times a day, daily COD measurements, and less frequent BOD, TKN, and TP measurements. The minimum required measurements are flow rate and either COD, BOD, or TSS. Additional measurements enhance the influent stream characterization. For WEST input, continuous measurements are needed. The new WEST 2024 sample includes a preprocessor that interpolates missing measurements and assigns weights for regression based on proximity to actual data. Measured values receive a weight of 1, while interpolated values get lower weights, decreasing with distance from actual measurements. The preprocessor, which is an R routine, reads from an Excel document and generates an output file. To import this file into WEST, set up the top-level interface variables for the input file headings. You'll see measurements and weights. If an input isn't connected to a file, enter zeros, as the fractionator interprets zeros as no measurement. Be careful to avoid carrying through default values. Then select the inputs, import your Influent file, connect the components, and generate as usual. This is the output of a fractionator simulation run. The graphs compare measured values with matched values, showing the result of fitted component concentrations. The fit's accuracy and smoothness are controlled by a relaxation factor. A higher factor gives smoother results, while a lower factor offers a closer fit to individual values. Where measurements are absent, the algorithm generates estimates, treated as second-class measurements with lower weighting in the regression. The matched values are plotted against these estimates since there is an absence of actual measurements. Adjusting the ratios used to generate these estimates can improve the fit, tuning the fractionator to a specific plant. To avoid unrealistic values like negatives, there are upper and lower limits on regressed values. If a variable consistently hits a limit, the limit might need adjusting. Diagnostics help tune the fractionator to your plant, particularly the regression error and the objective function minimized during regression. A spike in this function indicates a challenge in matching a particular point, possibly due to measurement inconsistencies or suboptimal estimation factors. By examining spikes, you can identify issues. For example, if a spike is dominated by TSS, it might indicate an unusual COD to TSS ratio. Address consistent patterns by adjusting estimation ratios. Improve simulation accuracy with the updated Influent Fractionator in WEST. Take the next step and upgrade to 2024.1 today.